go. Okay, ladies and gentlemen, welcome to Robotics, Year 7-8 Robotics. This video is for the students in both Robotics 1 and 2. Since I'm going to be away for the first 3 weeks of term, what I've done is I've created 3 introductory videos for you as a way to give you folks basically a chance to relearn some of the stuff that you might already know or get an introduction to robotics for the course, so that when I can get back, we can get back into some of the bigger challenges. Now, Robotics 2 students, you will be doing some of the same work that the Robotics 1 kids are doing. You may smash all the way through it, which is fine, but it's a chance for you guys to kind of remind yourself exactly what these robots can do and how they work and how the programming works as well. So, everybody, the first thing I'm going to talk to you about is one of the most important things you'll be doing in this class, which is your development and reflection journal. Okay, this is going to be one of the big things that I assess at the end of the unit, because it will have all the information in it that you've done on what you've accomplished, how you actually did it, how you beat some of the challenges, what you've learned in your code. All of that information is very important for both your marks, but also for any programming in general. Nothing is ever done without any kind of plan. Nothing is done without any kind of documentation or journal to follow along with the course of the project, to be able to basically show other people what is going on so they can come in and help to fix or modify the code or the project itself. On the classroom page, you will see that there is a journal. Hopefully it has created a copy for you when you signed up to the classroom. But that journal, I will show you it here, which I'm going to need you to fill in. You can change it, make it look however you want, personalize it, put some pretty pictures in. Please, no fluoro colors. I have to be able to read it and then even read it without throwing up. So use sensible colors and fonts, please. But as you can see, I've given you a couple of sections here. The first one is the outcomes that you're going to be assessed against. I'll quickly go through those. I'll be doing so in more detail when I get back, but plan and manage digital projects to create interactive information. So that is essentially planning a robotics project. And in this case, it's not really to create interactive information, it's to create a robot to do something, to fulfill a function, be it rescue a person, park without requiring any kind of remote control system. But you're going to be doing the full aspect of the project, so from planning to prototyping, testing, evaluating, redesigning, and retesting all over again. It's a cycle. The second one is define and decompose problems in terms of functional requirements and constraints. So you'll be getting a challenge. You'll need to break that challenge down into the different parts that you need to solve. And then you'll also need to be pointing out the parts that are difficult to solve. So the constraints, what can you use, what can't you use, what do you have to work around. The third outcome is designing user experiences and algorithms, incorporating branching and iterations, and test and modify and implement digital solutions. That's your programming. So you need to basically give me evidence of all 3 of these things in your journal, which will be easy to do because as you go through and complete the challenges, I'll be asking you to upload the sample of your code, whether it's in a screenshot or if we move into written code for the 7-8 Robotics 2 people. You'll be able to copy and paste it in, but you'll have commented on it. You'll have shown me what the different sections of the code mean, what they're for, how your code broke and how you fixed it. Putting broken code in your journal is great because you can show me how you recognized it didn't work and then how you changed it to make it work. In the second section here is a glossary of terms, which I'm going to get you to add to every lesson when you find a new term or maybe a new bit of programming language that you think is going to be important and that you'll be using over and over again. I've given you a couple of ones here to start with: define, design, implement, evaluate, iterate, and collaborate. They're all from the outcomes that you will see up on top, except for a couple, but you will be using all of these different things. So one of the first things you can do is go and actually find out what they mean, define those terms, which is of course the first term, define, hey. But then as you learn new terminology and new things, add them to your glossary. This is very important because in the different challenges and tests that you'll be doing later in the semester, you will be able to use your journal to complete those challenges and tests. Because the idea is that many of the different challenges I'll be giving you will use information that you have already learned, will use code that you've already written. However, you will have to modify it. But rather than just doing it from scratch again, use what you've already got. So the last little bit of the journal is basically what I kind of expect you to report on at the end of every session. So what did you learn? So today I learned the following. Here is some sample code that you might have done during the session, or in this particular case, here's a design or a plan that you did for your robot if you're more on the design trend of things rather than the programming trend. And then how will it help you? How will it help you? What did you learn? Those are some very important questions because this journal is all about reflection. Later on, you're going to be getting other people to give you reviews on what you did in a similar sort of way. So this is a good way to get started though. And because one of the hardest things to do is review your own work. Give yourself feedback that you can use to get better. And so that's something that you can develop through these journals. All right, so that's the journals. Now, the first step to this is usually to build the robots, but we're going to save that to a little bit later. We're actually going to jump into the first programming challenge that will be using the robot, which you'll see in the video in a second, and it's actually hopefully sitting on the teacher's desk, which you'll be able to plug into to test your programs on. So that robot, and I'll see if I can get some footage of it up here on the screen as well, but that robot is going to be, it's the Mark II, and it's got a very simple setup. It has two ultrasonic sensors attached to the front, and they're on ports 3 and 4, but you won't need to worry about those for this challenge. That's for the next challenge. They've also got two touch sensors that have been attached, kind of in a very remote control sort of way. Now, I'll quickly show you the video of what the robot needs to do here. So as you can see in the program, what we're trying to get the robot to do is when I click one of the touch sensors, the left wheel moves forward, and when I click the other touch sensor, the right wheel moves forward. Very basic decisions and very basic operations for the robot. So how do we do this? Well, we have to program the robot. So I'm just turning the robot on next to me right now because, and I'm going to be plugging it in using the cable. So I can connect it up to the computer so I can actually program it. Now, for you folks, because there is only one robot and there is many of you in the classroom, you are going to probably need to program first and then bring your robot over to test it on. So this is the part where sharing is caring. So if you see that there is a line of people waiting to use the robot, just wait in line patiently, and if you are testing, test it quickly. If it doesn't work, then let someone else come in and do a test while you think about what you saw, what you observed, and then you go back and work on your program again. So I'm switching over here on the main screen to the program. It wants me to update the bricks firmware. I might have to do that in the background because it's set to Robot C. Let's just have that working in the background. Oh. Okay, this is where we're going to cut and we're going to go through the different sensors. So we're going to do a little introduction to the sensors first of all. Now, the first one that you're looking at is this little guy right here. This is a touch sensor. Now, as a quick intro to sensors as well, I'll sometimes be referring to these as inputs because that's what they are. They are designed to give information to the robot for the robot to then use its outputs, its motors, to do something. So this is a touch sensor, and as you can see, it's got that little touch thing right on the front there. This is a sensor with only a couple of options. Not touched, touched or pressed, and then released. Those are the three different kind of settings that it can detect for. One of the common things that we use touch sensors for is whether or not your robot is touching something. So if it's come into contact and it's detected as being pressed, your robot can use that as a way to make sure it turns its motors off. Okay, so touch sensor on, off. That's the basic touch sensor. The next sensor is this little guy right here. Looks like a set of eyes because, funnily enough, they pretty much are. This is an ultrasonic sensor. Now, it uses pretty much a sonar to be able to detect the distance between itself and another object. So it's going to send out sound waves. They're going to go out. They're then going to impact against an object, reflect back, and hit the sensor. And the sensor is going to be able to use the time it takes for the sound to get to the object and back to determine the distance. It does that because, well, we know one of the variables, which is what's the speed of sound. So it can use that variable to work out the missing factor, which is how far away was the object. I'm going to give you guys a little challenge to see if you can actually figure out the maths of that. What is the speed of sound? And then what should be the distance based upon the time it takes to get from one place to another. Oh, firmware update's completed. Yay! We'll wait for that to reset. So that's the ultrasonic sensor. Now, it works up to a distance of 255 centimeters. It's not 100% accurate, but it's all right for what we're going to be using it for. So that's the ultrasonic sensor. Next sensor, one of my favorite ones, this little guy right here. This is a color sensor. So you can see it's got two little light sort of diodes. Oh, hey, robot's on. Two little light diodes in the sensor right here. One of them down the bottom is to create reflected light. So it essentially creates a little beam to allow you to measure reflected light. And the other one is the sensor, which actually detects the light. Now this can work in a couple of different ways. It can work